In this video we are solving an example about adding non-perpendicular vectors. The example says a hiker walks 4.5 kilometers due east, then makes a 30 degrees turn to the right and walks another 6.4 kilometers. What is the magnitude of the hiker's total displacement? Okay, so the most important thing in solving these problems is sketching a figure, diagram, vector diagram. Okay, we are talking about displacement, so our vector here is a displacement vector. Okay, so first we have a hiker walks 4.5 kilometers due east. As we know that east is here, east, and here is west, north is up, and south is down. Alright, so 4.5 kilometers east. Let's say these are, or make it a little bit shorter. This is 4.5 kilometers and pointing east. Okay, change the color. Now then makes a 30 degrees turn to the right. So the hiker is walking in this direction. After covering or moving a distance of 4.5 kilometers, he wants to make a 30 degrees turn to the right. To the right means in this way, in this direction. This is his right. So we imagine that the person is walking here, then he wants to turn to the right. Okay, so this is the original direction. He wants to go 30 degrees from this direction, not to the left. The left is up. To the right is down. From here, this is 30 degrees, and walks another 6.4 kilometers. 6.4. This is a 6.4 kilometers. Okay. What is the magnitude of the hiker's total displacement? The total displacement is from the starting point to the ending point, right? So here is the total displacement, and I will call this as resultant. This is A, and this is B, then this is R. And as you see here that those two vectors, A and B, are not perpendicular. To find the resultant of two non-perpendicular vectors, we use the law of cosines. The law of cosines says that the resultant square, the square of the resultant, is equal to the square of the first vector, A square, plus the square of the second, B square, minus 2A times B times cosine theta. Okay, now A and B are known, we know them, 4.5, 6.4. But theta, what is theta? As you know, that theta is the angle between A and B, between vector A and vector B. Here is vector A, and this is vector B. So angle theta, it's not the 30 degrees angle, it's the angle here. This is theta, which we don't know. Can we find it? Yes, we can. This angle from here to here is 180 degrees. So from the other side also it's 180 degrees. And the angle here is 30 degrees. So how much is left for theta? Theta is 180 minus 30 degrees, which is 150 degrees. So this is the most important part of the problem. When we know theta, we can find r. So here now, replace the values of a, 4.5 squared minus 6.4 squared minus 2 into 4.5 into 6.4 into cosine 150. R squared is equal to 879.65 kilometers. So R is equal to the square root of this answer, 879.65. So R is 29. What is this? 29.65 kilometers. So this is the total displacement of the hiker from the moment he leaves the original position until he stops. Okay, that's it. This is the answer. So the most important part here is the diagram. If you draw the diagram correctly, then applying the rule is very easy. Thank you. Bye bye.